Welcome to the Explainer. I am absolutely thrilled you're joining us today because we are looking at what is honestly the most important and maybe the most mind-bending technology story of the entire decade. We're going to break down this unprecedented economic shift happening right now in artificial intelligence. Look, we're entering an era where raw, natural language intelligence is going from this highly premium, closely rationed resource to a totally abundant, near-zero cost utility. But here is the wild part, the real catch. This incredible technological achievement is actually breaking traditional software business models. In some cases, it's threatening to completely bankrupt the very companies trying to use it. It is a literal paradox, and today, we're going to unpack exactly how it all works. Okay, to really grasp the sheer scale of what we're talking about, you only need to wrap your head around one staggering number: 280x. Stanford University's AI Index and Epoch AI put out some research recently showing that the financial cost of running a standardized, highly capable AI query collapsed by more than 280-fold over a span of just about 18 months. Just think about that for a second. A technology that is actively reshaping the entire global economy got 280 times cheaper in a year and a half. There's almost no historical precedent for that. Which naturally brings us to our central mystery. If AI is 280 times cheaper, why in the world are enterprise AI bills absolutely exploding right now? I mean, venture capitalists are out here coining terms like LLMflation, and cloud computing bills for startups are just going through the roof. How can something that is getting so cheap cost companies so much money? Well, to solve this paradox, we first need to look at the actual math behind this crazy price crash.
So let's kick things off with Section 1, the Great Price Collapse.
Let's look at the baseline cost to hit a very specific performance threshold, scoring at least a 42 on the MMLU benchmark. Back in November 2022, hitting that mark with a proprietary model like GPT 3.5 cost $20 for a million tokens. Now fast forward to October 2024. Achieving that exact same level of cognitive capability, but using an optimized utility model like Gemini 1.5 Flash 8B, it costs just 7 cents per million tokens. You heard that right, from $20 down to 7 pennies. This hyper-deflationary trajectory basically means that what was considered top-tier, premium frontier intelligence back in 2022 is basically just infrastructure dust today. So how exactly did the industry pull off this magic trick? That brings us right into Section 2, the engine of deflation. You see, this price freefall isn't just some clever marketing gimmick by cloud providers. It's a massive, structural revolution at the deepest engineering layers. First up, we've got hardware optimization. The industry is rapidly moving away from general-purpose GPUs and shifting toward highly specialized silicon. We're talking application-specific integrated circuits, or ASICs. Think Google's TPUs or Meta's MTIA chips. These things deliver vastly superior performance per watt. Second, there's model compression. Engineers are using techniques like pruning to literally snip away redundant parameters. And distillation, where a massive teacher model trains a super lightweight, highly efficient student model. And finally, we're seeing smarter architectures, like mixture of experts, or MO. With MO, instead of firing up the whole brain, only a tiny fraction of the neural network actually activates for any given query. Combine all these together, and we are suddenly doing vastly more work with incredibly less compute. Now, one really specific software technique driving a lot of this efficiency is called quantization. Basically, quantization is about reducing the numerical precision of a model's parameters. A good way to think about it is like taking a massive, totally uncompressed raw image file and converting it into a sleek, optimized JPEG. You massively slash the memory footprint and you increase the computation speed drastically. By moving from heavy 32-bit precision down to 8-bit or even 4-bit, engineers are seeing speedups of up to 2.4 times on much cheaper standard commodity hardware. And the crazy part? There's almost zero loss in actual benchmark accuracy. And honestly, when you strip away all those hardware improvements, the pure software gains are just mind-blowing on their own. Researchers over at MIT recently isolated these variables, and they found that pure algorithmic efficiency is improving threefold, literally 3x, every single year. Think about what that actually means. Even if computer chips completely stopped getting better today, like if hardware froze in time, software and architectural optimizations alone would let these models do the exact same cognitive tasks using only 1/3 of the compute resources each year. It's incredible. But here is where the narrative completely flips on us. Let's move into Section 3, the AI cost paradox. Let's finally dive into that twist I mentioned and see how dropping per unit cost are actually causing aggregate enterprise costs to absolutely skyrocket.
To really understand why AI budgets are breaking right now, we have to dust off an economic principle all the way from 1865 called the Jevons Paradox. William Stanley Jevons originally coined this to explain coal consumption, but the paradox dictates that when you increase the efficiency of a resource, it lowers the cost, which in turn dramatically escalates the aggregate demand and total consumption. Right? When the price of an AI token dropped by 99%, companies didn't just sit back and save 99% on their bills. Oh no. Instead, those dirt cheap prices unlocked entirely new, insanely more complex use cases. As a result, total enterprise AI infrastructure spending actually surged by 320%.
To see how this actually plays out in the real world, just look at how developer behavior has totally shifted. Back when inference was expensive, developers had to be super frugal. You built really contained tools like single-turn code auto-completion. A developer types a line, the AI finishes the line, boom, it consumes maybe 100 tokens. But today, now that tokens are basically free, developers are deploying these massive autonomous coding agent loops. Now you tell the AI to architect an entire microservice, and it just runs by itself. It writes the code, runs the test suites, self-corrects its own bugs, writes the documentation, and just loops continuously in the background. That single workflow can easily chew through over 100,000 tokens in one session. The demand for tokens is scaling exponentially faster than the price of tokens is falling. This runaway demand is creating a brutal capacity crunch that industry insiders are now calling LLMflation. Because literally everyone is suddenly building these super token-hungry autonomous agents, it's putting a severe structural strain on the cloud hosting market. Sure, cloud providers might be slashing the public on-demand prices for AI models, but if you're a company that needs to actually reserve high-availability, production-level GPU infrastructure, that underlying hardware cost is steadily climbing. We are in the middle of a literal inference famine.
Which leads us perfectly into Section 4, the product market fit trap. This macro-level economic weirdness creates a very, very dangerous reality for software companies on the micro level. A hot new startup can literally scale itself right into bankruptcy. In traditional software as a service, or SaaS, companies have historically enjoyed these absurdly cushy gross margins, like 70 to 90%. Why? Because once you build the software, the cost of a new user logging in and clicking some buttons is practically zero. High user engagement equals pure profit. But AI-native products completely break this model. They're operating at much tighter 50 to 60% margins because every single time a user interacts with the AI, it burns raw compute power. Your variable cost scales directly with your user engagement.
And that leads directly to the PMF trap, which plays out in 4 pretty inevitable phases. Step 1, a startup raises a nice seed round with a simple, predictable AI feature that they sell at a flat annual rate. Their margins look fantastic. But then, step 2, to keep those users engaged and happy, they do some feature expansion, adding in those deep, multi-step AI agent workflows we talked about. This leads to step 3, which is margin collapse. The new features are so awesome that user engagement totally doubles. But because of all those multi-step loops, the back-end compute bill actually quintuples. And finally, step 4, contract lock. The startup is stuck in these annual flat-rate enterprise contracts. That means their most highly engaged customers have suddenly become their least profitable cohort. The startup is literally stuck subsidizing their own customers' unprofitable usage. Ouch.
And this isn't just a scrappy startup problem. Listen to this absolutely wild reality shared by Brian Cantizaro, the VP of Applied Deep Learning Research over at NVIDIA. He noted that for some elite research teams today, the cost of the AI compute infrastructure actually significantly exceeds the direct payroll costs of the highly compensated human engineers using the systems. The computers are costing more than the rocket scientists. This is exactly why major corporations are suddenly slamming on the brakes. Recent reports show that tech giants like Microsoft and Uber have had to implement strict caps on AI usage budgets for their internal teams because the compute costs were just spiraling completely out of control. So how on earth do we fix this margin crisis before the whole industry goes broke?
That is exactly what we're covering in Section 5, Routing the AI Future. Simply put, to survive this, software architects can no longer just blindly send every single user query to the most expensive model on the market. That's a death sentence. Instead, they have to navigate a newly stratified market. The landscape is now split into 3 very distinct tiers. You've got your premium frontier models for novel, highly complex reasoning. Then you've got intermediate utility models, which are great for heavy context tasks like parsing huge documents. And finally, you have high-volume commodity models. These are dirt cheap and perfect for simple repetitive tasks like metadata extraction or autocomplete.
The really crucial takeaway here is the massive, massive price gap between these tiers. Look at the output prices. A premium closed-source model like OpenAI's GPT 5.5 standard runs roughly $30 per million tokens. But if you look at a highly capable open-source alternative like DeepSeek V4 Pro, it's just $3.48. We're talking about an 8.6-fold price gap for models that are actually remarkably competitive with each other on the standard benchmarks. So if you're a mid-sized enterprise running 100 million tokens a month, relying strictly on that premium tier is literally just lighting your money on fire.
So the ultimate engineering solution to avoiding this terrifying margin squeeze is a brilliant concept called semantic routing. Instead of a one-size-fits-all deployment, modern AI applications are using dynamic middleware. Basically, it acts like a traffic cop. When a user sends a prompt, the router instantly evaluates how complex it is. If it's a simple classification task, boom, it automatically dispatches it to a near-zero-cost utility model. But if it's a deep math problem, the system reserves those expensive premium frontier models strictly for those complex reasoning challenges. It's an incredibly smart way to optimize costs and absolutely crucial to prevent your product from getting locked into a single cloud provider's volatile pricing scheme. Which brings us to our final stop today, Section 6, the gentle singularity. As we wrap up this explainer, I really want to zoom out from the nitty-gritty of B2B software margins for a second. Let's look at the big macro picture. What this massive deflationary engine actually means for human progress as a whole. I want to anchor this with a pretty profound vision from OpenAI's CEO Sam Altman. He wrote, "As data center production gets automated, the cost of intelligence should eventually converge to near the cost of electricity." I mean, wow, we're climbing this long arc of exponential technological progress. Even with all the massive aggregate costs and infrastructure crunches we discussed today, the fundamental underlying cost of raw human-like intelligence is marching relentlessly, inevitably, towards zero. Altman summarized the end goal of all of this beautifully. We are building a brain for the world. What we are witnessing right now isn't just some petty API price war between a few tech giants in Silicon Valley. We are watching AI transform from this tightly rationed, premium novelty into an incredibly abundant, wildly accessible utility for all of humanity. It is an infrastructure build-out meant to empower billions of people, a future where literally anyone on Earth can summon unlimited genius to direct in whatever way they can imagine. And that leaves us with a truly memorable and honestly pretty provocative thought to chew on. We've seen how insanely fast the technology is accelerating. We know the absolute cost of intelligence is in free fall, and now we know the software tricks needed to harness it profitably without going broke. So the only question left for you is this: when intelligence becomes too cheap to meter, what will you build with it? Thank you so much for exploring the AI cost paradox with me today on The Explainer. Keep learning, keep building, and I will see you next time.